Okay, welcome to this short video on prime factors, lowest common multiple and highest common factor. Okay, so in this example question, we're asked to find the prime factors of 56 and 84, and then we're asked to find the lowest common multiple and highest common factor of these two numbers. All right, now I've just started by writing down the first few prime numbers. Okay, you should be familiar with those. And they're numbers that are divisible only by 1 and themselves. Okay, and any whole number can be written as the product of prime numbers, okay, except for 1. So any number above 1 can be written as the product of any number of prime numbers. So let's start by doing 56. Okay, now the most common way that you've probably seen is to put the number at the top and then to make a sort of factor tree where you come down like this and you split it into any pair of factors of 56. So I'm going to start with 2 and 28. Okay, and if any of those are prime, you just put a circle round them or a bar under them or something to mark them out. Okay, so that's the 2 is prime, but the 28 isn't, so I continue. And I split it into a pair of factors. So I'm doing 2 and 14. Okay, again, highlight any that are prime, any that aren't, you carry on. 14, I'm going to split into 2 and 7. Okay, now 2 is prime and 7 is prime. So that's it. We've completed the tree. And what we do now is we just say that 56 can be written as 2 times 2 times 2 times 7. Okay, we tend to put them in ascending order. Okay, and we also can write it as 2 cubed times 7. Okay, and sometimes the question says write it as the product of powers of prime numbers, and if it has the word powers in, then you would need to put the cubed in there like that. All right, now we can do a similar thing for 84. Okay, so I'll do that over here, 84, and that is going to be starting off with 84. Well, let's do something different this time. Let's start instead with 4 and 21. Okay, we could have started with 2 and 42, but just to show it will work however we start, as long as we get 2 factors. And the 4 goes into 2 and 2, both of which are already prime numbers, so we can put circles around both of those. The 21 splits into 3 and 7, and again that's it because they are both prime numbers. So we can stop there because we've completed the factorization of 84 to give me 2 times 2 times 3 times 7. Okay, and that could be written as 2 squared times 3 times 7. Okay. Now, just as a little aside here, I'll just show you an alternative method for finding that if you don't like doing the factor trees. So let's take 84 again. Just watch this. Start with 84, take the first prime number and divide it into 84 underneath like this. Okay, 84 divided by 2 gives me 42. Okay, now take that and check again to see if you can divide it by 2, which you can, okay, because it's an even number, giving me 21. Now again, look at it. Can I divide it by 2 again? No, because it's now an odd number, but I can divide by 3. So I take the next prime number and try that. 3 into 21 goes 7. Okay, can I divide by the next prime number, 5? No. Can I divide by 7? Yes, of course, because 7 into 7 goes 1. And there are my prime factors, 2 times 2 times 3 times 7. Okay, just as I got here. So it's an alternative method. I think most people tend to follow this method with the factor trees. So how do we find the LCM and HCF from this? Well, here's quite a smart way of doing it, which you may have seen before, but I will do it under here. So I'm going to produce a Venn diagram now. Okay, and what I'm going to do is make a box. Okay, a Venn diagram should always have a box, and inside two overlapping sort of circles, or really more oval shapes. Okay, so there's my box, and we've got to have a couple of circles in there, so let's do that now. Now, one of the circles represents the number 56, and the other one represents the number 84. So we label them like this: 56, and over here this circle is 84. Okay, now I take my prime factors and I take them out in pairs. So I'm going to take out the 2 from here because it matches a 2 from there, and that matching pair goes into the middle here, 2. Okay, I go along. Can I make another matching pair from both of them? Yes, I can. There's the 2 and there's another 2. So that means I put another 2 in the overlap. Okay, can I make another matching pair? No, because I've got a 2, but no 2 to match it with here. So that 2 ends up going on its own, just with the 56, but it doesn't belong in there with both the 84 and the 56. So I've now taken care of that one. Okay, I'll just change colour now to show you that that's been used up. Okay, and now I look at the 7, and that does pair up with that one, so that means I can put the 7 with the other 7, okay, as a matching pair. The 7 and the 7, they belong in here because they belong to both numbers. Okay, and finally I'm left with just the 3, which only belongs to the 84. Okay, now from that Venn diagram that I've drawn, I can immediately tell you that the HCF, the highest common factor of both numbers, is the product of the numbers in the middle. Okay, 2 times 2 times 7. Okay, which of course is 2 times 2 is 4 times 7 is 28. So that means that both 56 and 84 divide by 28, and there's no number bigger than 28 that does that. Okay, and I think you can quickly check for yourself that that's the case. All right, now what about the lowest common multiple? Well, it's easy. The lowest common multiple is simply the highest common factor, all right, multiplied by anything that's left over. Well, in this case, we multiply it by the 3 and by the 2, which are outside of the overlap, but inside the rings. Okay, and so I take 28, times it by 3 and times it by 2. Well, if I double it, I get 56, and if I times that by 3, that will give me, if I take 56 times 3, it'll give me 150, 168. Okay, so what does that mean? What does the lowest common multiple mean? Well, it means that 168 is the lowest number that will divide by 84 and by 56. Okay, that's what it means. So that's the answer to the LCM, that's the HCF, and that is the prime factorization of each number. Okay, hope that was helpful. Take care.